Okay, thank you so much for joining us in this spotlight interview in relationship to a protocol in protocols.io and a lab protocol in PLOS ONE. It is my real pleasure to be talking to Professors Franca Di Meglio and Clotilde Castaldo, who published Cardiac-derived extracellular matrix, a decellularization protocol for heart regeneration in PLOS ONE. Professor Castaldo earned her medical degree at Federico II School of Medicine and Surgery and completed her medical and clinical training at Cardiac-derived Hospital and her residency in sports medicine at Federico II University Hospital. She received a fellowship at the Cardiovascular Research Institute of the New York Medical College and at the Microneurosurgery Skull-based Lab of Cornell University in New York as well. Pursuing a career in both research and medical education, she earned her PhD in morphogenesis and tissue engineering from the Sapienza University of Rome. In 2005, she joined the faculty at the University of Naples, Federico II, where she was appointed as full professor in November of 2022. Since her postdoctoral training, Professor Castaldo has spent much of her career working on the involvement of microenvironment signaling in cardiac regenerative medicine. In more recent years, she has focused on the influence of myocardial microenvironment on cardiac progenitor cells and the development of a fully biological and potentially autologous cardiac bioconstruct to enhance and support myocardium regeneration. Professor Di Meglio earned her medical degree at Federico II School of Medicine and Surgery and completed her medical and clinical training at Cardiac-derived Hospital and her residency in sports medicine at Federico II University Hospital. She received a fellowship at the Cardiovascular Research Institute of the New York Medical College. Pursuing a career in both research and medical education, she earned her PhD in human and experimental morphology from the University of Bari. In 2006, she joined the faculty at the University of Naples, Federico II, where she was appointed as associate professor in October of 2019. Since her postdoctoral training, Professor Di Meglio has spent much of her career working on cardiac stem cells and exploring their potential in regenerative medicine. In more recent years, she has focused on the origin of human cardiac stem cells, the crosstalk between cardiac microenvironment and cardiac stem cells, and the development of engineered heart tissue for myocardial regeneration and repair. Thank you very much again to both of you for being here. So to begin with, I would like if you could briefly explain what the protocol we will be talking about is about, how to use it, and why this protocol is relevant.
Well, our protocol allows to produce decellularized extracellular matrix from the adult human heart by combining two detergents that are SDS and Triton in the same solution. And this combination results in a shorter incubation time, which means that samples, how long samples are immersed in the solution. And therefore, the procedure goes faster because the time is reduced, and also reduce are the disruptive effects of the detergents on the extracellular matrix. We use this protocol to obtain scaffolds of decellularized cardiac matrix that then we repopulate with the cardiac progenitor cells isolated from adult human hearts to create three-dimensional bioconstructs to study the interactions between cardiac progenitor cells and the cardiac microenvironment, but also the effects that the extracellular matrix exerts on cells and cells exert on matrix. And this both in a physiological and pathological condition. Additionally, since cardiac decellularized extracellular matrix can be recellularized with using different cell populations, such as cardiac myocytes derived from induced pluripotent stem cells, the platform obtained with our protocol could also be used to engineer the human myocardium and use it for drug development or drug screening studies. Furthermore, if the protocol is adapted to meet GMP regulations, the decellularized extracellular matrix so obtained might be used alone or in combination with cells for clinical applications.
Thank you very much. And may I ask, so what was the motivation to optimize the protocol? In other words, was there a similar protocol already published? And if so, why that protocol didn't work for your needs and you saw the need to create or to optimize this new protocol?
Okay, our aim was to decellularize the human myocardium to produce biological scaffolds for tissue engineering applications. And therefore, at first, our goal was to succeed in the complete removal of cells and cellular debris. We actually started out using previously published protocols, but most of the times they didn't work as well in our hands as the authors reported. So much so that for months, I thought that myocardial decellularization could never be achieved. It took over a year to find the perfect combination for us of chemical and physical methods to achieve this goal. And next, we aimed to produce a cardiac decellularized extracellular matrix with preserved structural integrity and biological activity. And thus we made several attempts and adjustments over the years to tune the procedures and ended up with the decellularized extracellular matrix highly preserved in its architecture and composition that is capable to support cell engraftment, migration, proliferation, and differentiation. And moreover, the amounts of extracellular matrix components retained by the cardiac decellularized extracellular matrix obtained with our protocol resulted significantly higher than the amounts reported by authors using different protocols.
Yeah, and it's quite remarkable, right? That that you spend weeks, months, and potentially, even a year working on optimizing a protocol. And traditionally, when people report these in a paper, it is summarized with a couple of sentences in the materials and methods. And all that amount of work that you and probably your trainees did goes unrecognized. And it's a huge amount of work.
Yeah, absolutely.
And can you speculate, or do you have any idea why those previous published methods didn't work in your hands or didn't work as had been previously reported? I know this is just mere speculation because it's hard to know, but do you have any ideas of what could be the reason?
Sometimes protocols, methods described by authors in the papers lack details of primary importance, such as the concentration of detergents, exposure time, the temperature at which the detergent act at their best. Other times, the description is misleading, just like some images, some pictures showing how, in the case of the decellularization, the samples are placed in the solution. And these were the main details that were affecting our protocol. I mean, our reproducing of that protocol in our setting.
Yeah, absolutely. Yeah, it's a lack of detail, right? That sometimes scientists have to guess what the right conditions were. And sometimes minor tweaks to the protocol could have a major impact on the results of the experiments. And so building on this discussion, I mean, you already invested a year in optimizing this protocol. And then you went the extra mile and put some effort into making it a step-by-step detailed protocol. What was the motivation for having this protocol in the platform, in this nice format that it's very detailed, and so to make it public?
What really prompted us to share our protocol on protocols.io were other researchers that we met mostly at congresses and meetings, who were constantly asking questions about the decellularization procedure we followed, because they were saying that they found it really hard to get good results, so hard that they very often switched to synthetic scaffolds. Since we experienced the same situation and also struggled with other groups' protocols and faced failure, and since it took a long time to develop our own protocol, we believed that sharing it in detail and in a step-by-step protocol would have saved time, samples, and reagents to other researchers.
I totally agree. But you even went further, and in addition to depositing the protocol in the platform, you had it peer-reviewed. So can you now explain on the motivations to submit the protocol to peer review to PLOS ONE?
Yes, the peer review process, in my opinion, should be first intended as a test for the target audience, and also as the chance to improve the protocol in terms of clarity and details, and should then make it more reliable for other researchers.
And can you let us know, either of you, how the feedback that you received from the PLOS ONE reviewers shaped the final version of your protocol?
Well, as regards the step-by-step protocol, we did. There were very few changes in the protocol after the feedback from the reviewers. We mainly added more details about the reagents, such as the supplier and the catalog number, and a set of icons that increased the readability overall. Okay. As regards the PLOS ONE, it was the peer reviewer feedback allowed us to add a lot of data, because they specifically asked for that. that certainly made the protocol stronger, the procedure more reliable to other researchers.
Thank you. And now going into the detail of the protocol itself, is there anything that you tried while developing and optimizing the protocol that didn't work and didn't make it to the final version? And my rationale for asking this question is exactly trying to save other users time in case they want to try something that you already did and you know it doesn't work.
Well, actually, I think that whatever we tried so far, because we started a long time ago, we started in 2016. There is nothing we've tried and it hasn't worked, at least not yet, that we have fixed somehow.
And as you know, as all scientists, I think, know, sometimes you have like a really nice protocol that works for you, and then suddenly it stops working. And it takes some troubleshooting to understand what is going on. Have you ever faced a situation like this with this protocol? Have you had to troubleshoot? And if so, why and how?
Well, as she mentioned before, yes, we fixed the issues several times over all these years, but not recently.
Okay.
And this was mainly done to reduce biological impoverishment and structural alteration of the extracellular matrix. So.
And can you tell the readers in your protocol what are the most critical steps, those that they really have to be careful when executing the experiment?
Well, we believe that our protocol is extremely simple, and if strictly followed, even the least experienced operator shouldn't go wrong easily. In fact, in our view, this is a major strength of the protocol. However, elite experience with the cryostat sectioning is required to carefully prepare appropriately sized tissue chunks and to attach them to the cryostat chuck. And care must also be taken when removing and replacing the solution in the 50 ml falcons to avoid damaging the sectioning with surgical forceps or slipping them off with the solution. And usually we rotate the falcon until the section adheres to the wall, and then pour and add the solution from the side opposite to the one where the section is located. So we avoid any damage.
Okay. And since the time of publication, have you tried to optimize this protocol even further or to use it for a different application?
Yes, we have. Actually, to decellularize the larger samples, not sectionings, by using a specially designed and patented sample holder, but that's another story.
Okay, and are you considering in making these new optimizations public as well?
Yes.
Yes.
Yeah,
why not?
And now I would like to know if you can tell us what has been the significance of publishing the protocol and the paper for your careers of both of you.
Well, this lab protocol, I think, had no particular significance for us, but we are...
Yes, because we are senior.
Yeah.
As you can see, we are senior researchers.
But we are persuaded that for the young researchers who co-authored the publication and participated in the review process, this was a chance not only to add a paper to their records, but more importantly, to learn that research means sharing results and methods, and that methods must be as detailed as possible to be repeatable and to use to be of use for other researchers.
Thank you. And so, and just now to wrap up, it has been like a really nice conversation and very enlightening of how you struggle to do experiments based on what had been reported before, and that prompted you to really develop a new protocol or optimize a protocol with as much detail as possible and make it public. So other researchers, your colleague, they don't have to go through all the hurdles that you had to solve to actually do your experiments. Is there anything that we haven't discussed that you would like to mention before we wrap up?
No.
No? Okay.
Nothing comes to our mind.
So thank you again so much for sparing some time to talk to me. It's been a pleasure. And again, I think it's been very, very informative and enlightening.
Thank you for the chance to do so, to share even this other than the protocol with other researchers. I hope to have feedback from them. I mean, it would be very nice to know that our protocol actually worked also in their hands as it does in our